Hello guys, in the previous video, which was also the first video of this chapter, we discussed about the subatomic particles. The subatomic particles. The subatomic particles include the protons, the neutrons, and the electrons. We discussed about the mass and charge of these subatomic particles. And we discussed in detail about electrons. Who discovered electron? Electrons were discovered by J.J. Thomson. The experiment he used to determine the electrons was called cathode ray discharge tube experiment. Cathode ray discharge tube experiment. I will give you a review of this cathode ray discharge tube experiment. So what J.J. Thomson did, he took a discharge tube which was connected to two electrodes. One electrode was cathode, which was the negatively charged electrode. Second electrode was the anode, which was the positive charged electrode. The discharge tube was connected to a vacuum pump whose role was to maintain a low pressure in between the discharge tube. Low pressure. Also, the discharge tube was connected to a high voltage generator or an electric circuit. As soon as it was switched on, J.J. Thomson was baffled to see a green glow at the anode end. There was no such glow at the cathode end, but there was a green glow at the anode end. By seeing this green glow at the anode end, he concluded that there is something which is traveling from cathode and is attracting towards anode. As there was no such green glow on the cathode, he concluded that something is traveling towards anode and which is attracted towards anode. And since anode was positive charged, he concluded that something which is traveling was having a negative charge. He gave them the name cathode rays. The things which were traveling, he gave them the name cathode rays because they were traveling from cathode to anode. And they were negative charged because they were attracted towards the positively charged electrode. Later, characteristics of these cathode rays were established. Some of them were cathode rays traveled in a straight line. Cathode rays were deflected by electric and magnetic fields. And the most important characteristic was that cathode rays carry negative charged particles, which were later called electron by J.J. Thomson. Which were later called as electrons by J.J. Thomson. After discovering electrons, J.J. Thomson was able to measure ratio of electric charge to mass of electrons. So, this charge to mass ratio of electrons were later calculated by J.J. Thomson, which was the experiment which led to this discovery. So this was the setup of an experiment which led to the charge to mass ratio of electrons. You can see here the setup. Now, I will be telling you in detail how this worked and how the charge to mass ratio of electrons were discovered. J.J. Thomson applied electric and magnetic field perpendicular to each other. Here are the plates which led to the establishment of electric field. The poles of the magnet, the north pole and the south pole, led to the establishment of a magnetic field. So, both magnetic and electric field were applied perpendicular to each other. You can see here electric and magnetic field were perpendicular to each other, as well as they were perpendicular to the path of electrons. So electric field was perpendicular to magnetic field, and both of them were perpendicular to the path of electrons. When electric field alone was turned on, the electrons strike at point A. Electric field was on, but magnetic field was off. And in that case, the electrons strike at point A. When only magnetic field was there, the electrons strike at point C. In the absence of both electric and magnetic field, the electrons strike at the point B or position B. Also, electric and magnetic fields were adjusted by him in such a way that the electrons again strike at point B. So there are 4 cases. When electric field was on, electrons strike at point A. When magnetic field was on, they strike at point C. In the absence of both electric and magnetic field, they travel in a straight line and strike at point B. Also, when electric and magnetic fields were adjusted, electrons were able to strike at point B again. And so, on the basis of these deflections of the path of electrons, J.J. Thomson was able to determine the charge to mass value of electrons. Which was 1.7588 into 10 raised to the power 11 coulombs per kilogram. So, charge to mass ratio of electrons were discovered by J.J. Thomson through the deflections, and it came to be this value, which is of 1.7588 into 10 raised to the power 11. Next, now we know that J.J. Thomson was able to determine this value of charge to mass ratio. But how was the value of charge determined? The value of the charge were determined by an experiment called the oil drop experiment. It was carried out by Millikan. What happened? So this is the setup of the oil drop experiment. And what happened in it? I will tell you in detail. This setup includes an atomizer. The role of the atomizer was to spray oil particles in the form of a mist. Oil particles or droplets in the form of mist. You can see here, atomizer is spraying the oil, and these are the oil droplets which are in the form of a mist. Here, they are allowed to pass through a small hole, and the metal plate here is charged. Positively charged metal plate is here, whereas negatively charged metal plate is here at the other end. This shows that an electric field is there inside this another chamber. So this is the first chamber where just oil droplets were passed. First chamber, and this is the second chamber where electric field was established. The rate at which these drop falls were measured by a viewing microscope. Rate of fall of oil droplets were measured by this microscope. So, Till now we have discussed the role of atomizer, the role of first chamber, the role of second chamber, and the role of viewing microscope. Here we'll be discussing the role of ionizing radiation. X-rays were passed through the chamber. X-rays were passed through second chamber to ionize the air inside. So, X-rays were passed to ionize the air inside. And the air inside collided with the oil droplets, making them charged. So now, we were having charged oil droplets. And there were three types of force acting on these charged oil droplets. Gravitational force, electrostatic force, and viscous drag force. Viscous drag force. Through this experiment, Millikan gave the result that magnitude of electric charge this is a very important result. Magnitude of electric charge Q on oil droplets was always a multiple of electric charge. Was always a multiple of electric charge E. Which led to the statement Q is equal to NE, N is equal to, where N is 1, 2, 3, 4, 5, and so on. So, this implied that when electric field was, the magnitude of electric field was increased, the charge also increased. When magnitude of electric field was increased very much, the charge also increased very much. But the value by which, or the rate of increase of the charge, was integral multiple. That is, it wasn't fraction, it was integral multiple. It can be, so this led to the result that Q is equal to N into E, where N can be 1, 2, 3, 4, 5, where E is a specific value, and Q will calculate the overall charge on the oil droplet. Through this oil drop experiment method, value of E was determined, which came to be 1.6 into 10 raised to the power minus 19 Coulomb. So, this was the value determined by Millikan through the oil drop experiment. Now, how the value of mass of electrons were determined? We have this charge by mass ratio value, which was determined by J.J. Thomson on the basis of deviations. Deviation of electrons in the presence of electric and magnetic field. We were able to calculate the charge of an electron. Who calculated it? Millikan calculated it with the help of oil drop experiment. So how we were able to calculate the mass of an electron? Some simple calculations were observed. So let this value be x. And we know this value, which is 1.758820 into 10 raised to the power 11. So let E by M be x. We have this value also by oil drop experiment method. We have this we have this. We want to calculate this. What we will do? Simple, cross multiply. E is equal to m into x. We want this. So m E by x. Mass of electron will come like this. The calculations are here already. E was 1.6022 into 10 raised to power minus 19 coulomb, whereas x, which was the ratio, was 1.758820 into 10 raised to power 11. Dividing this, we will get the mass of the electron, and this is the actual mass of electron, 9.11 into 10 raised to power minus 31 kg. So now we know who discovered electrons, how it was discovered, what was the value of charge to mass ratio of electrons, what was the value of the charge on an electron, and what is the value of the mass of an electron. All these things about electron we know. Now, moving forward to protons. Discovery of protons were done by Goldstein, and through an experiment which was called the Anode ray discharge tube experiment. What he did, he took the same discharge tube, which J.J. Thomson took in cathode ray discharge tube experiment. But a little modifications were done in this discharge tube. Here, you can see the setup here. Here is the discharge tube. And the modifications which Goldstein did was that he took a perforated cathode. Instead of a normal cathode, he took a perforated cathode. Perforated cathode means the cathode is having holes. Okay? So, Goldstein took a perforated cathode. Again, the discharge tube was connected to two electrodes. One was negative charge electrode, one was positive charge electrode. The discharge tube was connected to a vacuum pump whose role was to maintain a low pressure. The discharge tube was connected to a high voltage generator, and as soon as it was switched on, he was baffled to see a result. He was baffled to see a red glow here, just behind the cathode. So, what he discovered? So, Goldstein discovered that when perforated cathode was there, something was there which was traveling from anode to cathode, as there was red glow at this side. This led to the result that since something is attracted towards the negative charge electrode, which is the cathode, there might be positive charge inside it. Goldstein named something traveling from anode to cathode anode rays, as they were emerging from anode and were attracted towards the cathode. Two more names were given to the anode rays. One was the canal rays. Another name was the channel rays. This is because they are traveling through a cathode which is having holes, or perforated cathode. That's why they were given the names canal rays, channel rays, or anode rays. These rays traveled in a direction opposite to that of cathode rays. Cathode rays traveled from cathode to anode. Cathode rays. Whereas anode rays traveled from anode to cathode. Again, experiments were done to determine the characteristics of these anode rays. One experiment was that when an electric field was applied perpendicular to the direction of these rays, deflection was observed. This positive and negative represents electric plates here. Positive charge electric plate and negative charge electric plate. And electric field is established inside it. So when these anode rays were allowed to pass, deflection was there. And deflection was at the side of this negative charge plate, which led to the discovery that the particles in the anode rays are having positive charge. So, when an electric field was applied perpendicular to the direction of rays, they deflected towards negative plate, which meant that they carry positive charge. This led to the discovery of protons. Also, the charge to mass ratio and the mass of the protons were calculated through experiments. So what was the difference between anode and cathode rays and how their properties vary from each other? We will have a quick look on these properties too. So the property is motion. Cathode rays, they travel in straight lines. Anode rays, they also travel in straight lines. They travel in straight line was proved by that experiment in which in a discharge tube a metal cross was there and a shadow was placed exactly behind this metal cross. This led to the result that cathode rays traveled in the straight line. Type of charge. Cathode rays were deflected towards positive plate. When an electric field was established, we saw that cathode rays were deflected towards the positive charge electric field plate. Whereas, when an electric field was established, the anode rays were deflected towards the negative charge. This meant that anode rays were having positively charged particles, whereas cathode rays are having negative charged particles. So, particles present in cathode rays were called electrons. And particles present in anode rays were positively charged particles. Later, the name protons were given to them. It was also noted that electrons present in the cathode rays had the same charge and mass. It wasn't the case in the case of anode rays. Origin, we know they originated from cathode, whereas they were produced in the space between anode and cathode. So what was the experiment that led to the discovery of neutrons or neutral charged particles, the particles having zero charge? This was the setup of an experiment performed by James Chadwick, where alpha particles. Now, what are alpha particles? Alpha particles are helium ion with +2 charge. Alpha particles were projected towards a beryllium foil. Alpha particles were projected towards a beryllium foil, and it was noted that some mysterious particles were emitted out. And the mysterious particle had a neutral charge. When paraffin wax was placed in front of this beryllium foil, it was noticed that some charged particles emerged out, and the charge was positive. So, protons emerged out. The current mass of these ejected atoms were estimated, which led to the conclusion that the mysterious rays consisted of particles having the same mass as that of protons. As to shoot out protons with such a high speed, these chargeless particles also must be the same size as that of protons. The neutrons were shooting out protons. And if we need to eliminate something, the mass should be same. Their mass should be same. This was discovered that protons were getting eliminated when neutrons were striking, or neutrons or some mysterious particles were striking on a paraffin wax. And since neutrons were able to eliminate protons, they are having the same charge as that of protons. So through this experiment, the charge and the mass of neutrons were discovered by J. Chadwick. What was the conclusion? The conclusion was that electrons were discovered by J. Thomson through an experiment which was called the cathode ray discharge tube experiment. The charge and mass of electrons, the value of charge and mass of electrons were discovered. Protons were discovered by Goldstein through anode ray experiment, and charge and mass of protons were also discovered. Neutrons were discovered by Chadwick with the bombardment of beryllium with alpha particles. Charge and mass of neutrons were also discovered by J. Chadwick. So, we have completed our first portion of this chapter, which is subatomic particles, through these two videos. And from the next video, we will be studying in detail about the atomic models, the drawbacks, the advantages, and many other things of the atomic models proposed by J. Thomson, Rutherford, Niels Bohr, Schrödinger, and more. So, keep learning and all the best.